I am Anne Lesage. I am working for the CNRS, the National Center of Research in France, and at the High-Field NMR Center in Lyon. What I am working on is developing dynamic nuclear polarizations to improve the sensitivity of this spectroscopy and tackle challenging substrates such as surfaces or complex biomolecular assemblies. To enhance the sensitivity of NMR, so we are exploiting this technique called Dynamic Nuclear Polarization, or DNP, which rely on the huge polarization of electrons and on a transfer of polarization from electrons to nearby nuclei. And by doing this, you can enhance the sensitivity of solid-state NMR spectra by up to 2 orders of magnitude, and this corresponds to huge reduction in experimental times and really opens new horizons in terms of characterization of challenging systems. So I have been working a lot over the last years on characterizing supported catalysts, for example. So describing the active sites in heterogeneous catalysts. So usually, when you have an efficient catalytic systems, in many cases, you don't know exactly what is the structure of the active sites at an atomic level, and this is what NMR can bring. So recently, we disclosed the active sites of metal and HC complexes, for example, involved in key modern chemical reactions. I think solid-state NMR over the last few decades, and especially over the last past years, has really emerged as a unique analytical tool to disclose structures of materials, but also of biomolecular assemblies. And from the knowledge of atomic scale structures, then we can design in a rational way. We can understand how, for example, what drives the properties of a given materials. If we understand what is the structure of these materials at an atomic scale, and then design in a rational way materials with improved properties. So this in the field of catalysis research, but also in the field of energy, of environmental research, and of course in the field of health, vaccine formulations. For example, if you want to develop better vaccines, you need to understand, for example, the interface between adjuvant and antigens, and this can be done very efficiently by NMR and potentially also by DNP-NMR.